Okay, so in this video, we're going to find exact values for the trigonometric functions for angles pi over 6 and pi over 3. So what we're going to do is we're going to create a couple triangles. Okay, so let's start with an equilateral triangle. Okay, and let's just say that the sides are all 1. Okay? And now, if it's an equilateral triangle, that means all the angles are the same. If all the angles are the same and all the angles add up to 180 degrees for a triangle, that means each angle is 60 degrees. Okay? So what I'm going to do so that I can get a 30, 60, 90 triangle is I'm going to take my triangle that's an equilateral and I'm going to cut it right down the middle. Ching, just like that. So this altitude here makes a 90-degree angle here. This angle up here gets cut in half, so 60 degrees becomes 30 degrees over here for this side and 30 degrees over here for that side. Okay? So what we have going on here, well, when I cut this triangle in half, this side is a half over here, and this side is a half over here. So now let me write this triangle out. Okay, so I have a side that's 1/2. This angle here is 60 degrees. This is 90 degrees, and that's 30 degrees. This is equal to 1. Okay, there's a theorem that you learned way back when called the Pythagorean Theorem. Now, the Pythagorean Theorem says this. It says a squared plus b squared equals c squared. For right triangles, we got a 90-degree angle here, so that's a right triangle. So what's going on here? It's the leg squared plus the other leg squared equals the hypotenuse squared. So right now, the hypotenuse is 1. That's the longest side. This is a leg, and we need to figure out what this value is here. So I'm going to use Pythagorean Theorem. So I take a leg squared plus a leg squared. So I have 1/2 squared plus x squared equals the hypotenuse squared, 1 squared. So that's 1/4 plus x squared equals 1. Subtract a 1/4 from both sides. I get x squared equals 3/4. To get x by itself, I'm going to take the square root of both sides. Now I have a plus and minus, but the thing is, whenever I'm dealing with a side length, I only want the positive one. So I only take the positive one of these. And so this is going to reduce to the square root of 3 over, now what's square root of 4? That's 2. Okay, so this side here, I'm only looking at the positive one, the square root of 3 over 2 for that side over there. Okay, so what I've done now is I've derived for you the 30, 60, 90 right triangle. Okay, so if I want to find on a unit circle, right? So on a unit circle, if I'm going to do the pi over 3 angle, okay, so let's do a unit circle here. Okay. So 60 degrees, this is equal to pi over 3 in radians. Okay, so this is the one that I'm going to work on first here. Okay, so pi over 3, 60 degrees. So what am I doing? I'm starting on my initial side here, and I'm rotating up 60 degrees. Okay, to this point right here. Let me move this down just a little bit. Okay. So if I'm going to figure out what this value is, well, what do I know? This point right here is at 0, 0. Okay. And I want to know, what is this x comma y value up here at the point P? Okay, so what I can do is I can draw a triangle. Okay, so what do I know? A unit circle has a radius of 1, just like this has a radius of 1. The x value, how far we go out to the right here, is 1/2. And the y value, how far we go up, is square root 3 over 2. So what does that tell me? That tells me that this point here is 1/2 comma square root 3 over 2. How about that? All right, so that gives me a way to calculate the trigonometric functions for pi over 3. So the sine of pi over 3, so the sine is the y value, that's square root 3 over 2. The cosine of pi over 3, that's the x value. The x value is 1/2. All right, the tangent of pi over 3, what's the tangent? That's y over x. So what does that equal? That's a square root of 3 over 2 divided by 1 over 2. Now to do this, I keep, change, flip. So I keep square root 3 over 2 the same, change division to multiplication, and I flip to get 2 over 1. Guess what? The 2's cancel, and I get square root 3. Okay, so square root 3 is my answer there. Now, for cosecant pi over 3, that's 1 over y, that's a reciprocal of sine, so that's 2 over the square root of 3. I would be fine if you left your answer like this, but there's some teachers and some books that they want to rationalize the denominator. So we're going to rationalize the denominator here. Square root 3 over square root 3. Multiply 2, I get 2 square root 3 over square root 3 times square root 3 is just 3. Okay? The next one, secant pi over 3. Secant pi over 3, that's 1 over the cosine, so 1 over the cosine, so that's 1 divided by 1/2. Keep, change, flip. That gets me 2. The last one is cotangent pi over 3. Cotangent pi over 3, that's x over y, the reciprocal of tangent. Oh my goodness, so that's 1/2 divided by square root 3 over 2. So this is keep, change, flip. So I get 1 over the square root of 3. This will simplify, multiply top and bottom by square root 3. I get square root 3 over 3. Okay? Alrighty. Now, that covers pi over 3. Okay, so that's going to cover pi over 3. All right, so what about doing the 30 degree? Well, I can still use this triangle here. Okay, I can still use this triangle. Only thing I got to do is rotate it a little bit. Okay, so I just rotate it a little bit. So now this is my 30 degree angle. This is my 60. And this is my 90. So that shortest side is 1/2, this side is 1, and this side's square root 3 over 2. And so there I've got my central angle. Okay, so let me draw a picture again, and I'll show you how to use this on your unit circle. So for this one, this is pi over 6, an angle of pi over 6, which is 30 degrees. So the 30 degree angle, so if I'm starting here and I rotate up 30 degrees, okay, so let me try that a little bit better. So a 30 degree angle, all right? So I want to know what x comma y is here for the 30 degree angle. Well, how do I do this? Okay, I use my use my triangle that I have right here. Okay, so I'm going to drop down, make a right angle. And so what does that tell me? The radius is still 1 like it's always been. This side right here, that's this side right here, that's square root 3 over 2. This height right here, that is 1/2. So what is this point? The point, the x value is square root 3 over 2. The y value is 1/2. Huh, that looks a whole lot like the other point we just found up here, right? The only thing different between this point and that point is it looks like the x and the y swapped. And in fact, they did. If you think about it, they're reflected across this line y equal x going on here. Okay, and we'll talk about how to figure out that point on the unit circle in another video. But the only thing that's different is that we're swapping around the x and the y values for the 60-degree angle versus the 30, which makes sense because we're finding it from the same triangle. Okay, so hopefully you see the connections here. All right, so let's do the trig values. Okay, so the sine of pi over 6, sine of pi over 6, that's the y value. The y value is what? The y value is 1/2. The cosine of pi over 6, that's the x value. The x value, square root 3 over 2. Tangent, pi over 6. Tangent is y over x, which is what? 1/2 divided by square root 3 over 2. What's that equal to? That's keep, change, flip. That's 1 over square root of 3, which is equal to square root 3 over 3. All right. Now for the second part, cosecant pi over 6, that's a reciprocal of sine. So that's 1 divided by 1/2, which is 2. Secant pi over 6, this is 1 over x, that's 1 over cosine. So that's 1 divided by square root 3 over 2. So reciprocal, square root 3 over 2 is 2 over square root 3. When I rationalize, I get 2 square root 3 over 3. The last one is the cotangent, pi over 6. This is x over y. This is going to be what? This is going to be, oh my goodness, what was the x value? The x value was square root 3 over 2. What was the y value? It was 1 over 2. Keep, change, flip. I get square root 3, just like that. Okay? So hopefully the triangle that we derived here at the very first, it's not too hard to rederive the triangle. All you need to know is you start with an equilateral, split it down the middle, and you got to know Pythagorean Theorem to get that square root 3 over 2 side here. Okay? And you're going to use this so much that you're just going to know this like second nature. All right? So that's how we derive for the 30-degree angle and the 60-degree angle. In the next video, we're going to talk about how to do it for the 45-degree angle that was briefly mentioned right here on this reflection line.